Okay, so I'll share my screen with you guys. Let's get to work. Missed 2 classes because went to a trip but finished the lectures. All right, so the classes that you probably missed were of functions, but it's okay if you missed those classes. I mean, you should catch up. You should watch the recordings. But what we're doing today is differentiation. Okay, now we still have some more past paper questions of functions to cover, which we will do, but later. Okay, I just want to get done with the syllabus so that we can start our practice. So yeah, today we are starting differentiation. Okay, so what do you guys know about differentiation? If you know anything at all. Anyone would like to say something about differentiation before we start? Seems fun, not conventional math. Yeah, you could say that. Yeah, so see, trigonometry, differentiation, integration, they're all part of calculus. Okay, let me write this again. Was fairly simple in IGCSE. Oh, IGCSE differentiation was a joke. Differentiation that we did in IGCSE Math, was literally a joke compared to what we're about to do. Okay? I'm not trying to freak you guys out, just stating the obvious. Okay? Rate of change of a function. All right. So all of this falls under differentiation. So under differentiation, yes, you have rates of change. You have stationary value, maximum, minimum value. You have equation of tangent, equation of normal. And you have the regular differentiation. Okay? So, yeah. So basically, let's understand what is the whole purpose of differentiation. How about Cambridge AdMaths O level? Okay, so those of you who've done differentiation in AdMaths, you would find AS differentiation a lot easier because you know what? We don't have product rule and quotient rule. Okay, and we don't have differentiation of trigonometric functions. We don't have differentiation of logarithm. We don't have differentiation of exponential functions. At least not in P1. We have that, but we have it in P3. Okay, so before we start off with differentiation, some of you who did IGCSE Math last year, you guys would have done a very basic form of differentiation. Okay, I'm talking to students who did IGCSE Math. Okay, I should mention here we have differentiation in IGCSE Math, but we don't have it in O level Math. Okay, and I'm not talking about AD Maths right now. I'm talking about just O level and IGCSE Math. You have a very fraction of differentiation in IGCSE Math, but none of it in O level Math. So the whole idea of differentiation is to basically find the gradient, okay? And that gradient could mean a lot of things. That gradient could mean rate of change. It could mean later on when we're doing M1, we'll see how that can mean speed. It can mean acceleration. It can mean a whole lot of things. But the whole purpose of differentiation is to be able to find the gradient. Okay. Now, gradient of what exactly? So suppose that we're in O levels right now, okay? And if we have a straight line in front of us and we have to find out the gradient of this straight line, what are you going to do? Best news, yeah. So AdMath students, you guys can relax a little, but again, don't take it lightly. All right, it's still important. Yeah, rise over run. So can you be a bit more specific? What should I do if I have a straight line in front of me and I want to find out the gradient? What should I do? Yeah, we just need 2 points, okay? And then of the 2 points, we need the x and y coordinates, okay? Their x and y coordinates is what make up a point. So then what are we going to do? We're going to use the formula rise over run, which is basically y2 minus y1 over x2 minus x1. So let's say this is x1. Let's say this is x2. Naturally, this becomes y1. This becomes y2, okay? So we will use any 2 points on the line where we'll use the formula rise over run, and then y2 minus y1 over x2 minus x1. Does it matter what points I use? Let's say we have 20 different students in class and all 20 of them use different points. Will it matter? Will they all end up with 20 different answers or the same answer? Same answer, obviously, because it's a straight line. You can see the steepness of the line is constant, which is why we say the gradient is constant. Okay, the gradient, irrespective of the points that we use, will end up with the same answer. So we say gradient is constant. Okay. Now, Suppose we are still in O levels in IGCSE and we haven't done differentiation yet, and we are given a curve. Okay, any curve for that matter. Let's say a quadratic curve. Okay, here it is. Let's say we are given a quadratic curve, and we are asked to find out the gradient of this curve at any random point. Let's take this point. What do you do now? Let's say the question says, find the gradient at x equals to x1. So first of all, gradient of a curve, what do you think? Is it going to be the same or is it going to be changing constantly? What do you think? It's changing. Okay, why? Because if you look at a curve, you can see that the steepness does not remain the same. Okay, if the steepness remained the same, it would have been a straight line. The steepness is changing. Like, for example, it's decreasing, 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 and for a fraction of a second, you can say, for a very small interval, it is what we call stationary. Why? Because it reaches its minimum point. More about that later. And then it's starting to increase. And you can see that I know as we're increasing the value of x, it's getting more and more steeper. Okay. So how exactly will we find out the gradient? Yes, we will draw the tangent. Okay, so at x equals to x1, we draw a tangent. Okay, this is what we did earlier. This is not something we'll have to do right now. Keep that in mind, please. Okay, we draw a tangent and then we find out the gradient. Okay, so what do? We draw a tangent at x equals to x1. And then on the tangent, we find 2 points and use the gradient formula. Okay, this is something that you guys should know already. Okay, we pick 2 points. Not that we're going to have to do this, okay, but something that you guys did back in O levels. So we'll pick 2 points and then we'll use the gradient formula. Okay, so not exactly new, nothing new so far. Now we look at the calculus side of things. It will stay constant? No, gradient of the tangent will obviously stay constant, but the gradient of the curve will not remain constant, which is why if let's say you are asked to find out the gradient at some other point, let's say you're now asked to find out the gradient at x equals to x2, what are you going to do now? You will have to draw another tangent. Why? Why can you not use the gradient of this tangent? Because it's a curve. And a curve means that the steepness is constantly changing, which is why you will have to draw tangents at different points in order to find out the gradient of the curve at that point. Okay?
Sir, how many points in total?
What do you mean, how many points in total?
Like, in order to find the gradient of this curve, how many minimum points I should have?
2
Like
points.
tangents.
2 points. No, you will need the tangent at the point at which you find the grade. You want to find out the gradient, and then once you've drawn the tangent, from that tangent, you need 2 points so that you can use the gradient formula. Because the gradient
How
formula,
many tangents I will need?
that depends on the question. If the question asks you to find the gradient at x equals to x1, then you will draw a tangent at x equals to x1. If the question says find the gradient at some other value, then you will draw a tangent at that value. Okay, so it depends on the question. And having said that, you don't have these kind of questions in AS. This is something that you did in O levels. O levels or IGCSE, whatever you did. Yeah, under graphs of functions. Okay? Now, like I said, nothing new so far, hopefully. Now we're going to look at the differentiation side of things. Okay? This is not something that we do in differentiation. Okay? Differentiation is a more algebraic approach. Okay? And if you guys remember, so let me see if you guys remember. If let's say you found the gradient of the curve at a certain value of x, you found the gradient of tangent, you think you're going to get the exact answer? No. Okay, so chances are there are 10 different students and they'll end up with 10 different answers and they could still all be correct. Why? Because there used to be a range of acceptable answers. And the reason why there was a range of acceptable answers is because this is not a very accurate method. Okay, which is why, in fact, if you remember, I doubt you guys would remember so many details, but the question always said estimate the gradient. Somebody's mic is open. Yeah. So the question would say estimate the gradient of the curve at so and so point. Okay. Now, let's introduce ourselves to differentiation. Okay. If let's say you come across the same question in differentiation. Now, as always, first we're going to look at the theoretical side of things. And through that, you won't understand the entire concept. Okay. Then when we look at some examples, then I can guarantee you will understand how the whole thing works. Okay, so don't immediately start asking questions. Just hold on to your questions, write them down if you're afraid that you'll forget. And then once we're done with a couple of examples, feel free to ask as many questions as you like. Okay? So let's say the question says find the gradient of y equals to f of x at x equals to x1. Okay, and for our understanding, let's visualize what exactly we're doing. Okay, so x equals to y equals to f of x is a curve. All right, let's say it's a maximum curve. Okay, here it is, x, y, and we're asked to find out the gradient at x equals to x1, which we know that if we had to do this graphically, we would make the tangent at x equals to x1 and then find 2 points to plug in the gradient formula. Okay, but what if we are supposed to do this through differentiation? Then there are 2 steps. Okay, it's a 2-3 step process. Step 1 is that you find dy by dx. Now, how do you find out dy by dx? What does that mean? All that we're going to look into later on. Or dy by dx or f prime of x. Okay, now understand this. When you have y and when you differentiate it, it becomes dy by dx. When you have f of x and you differentiate it, we call it f prime of x. Okay, this is to distinguish between the equation of the curve and what we get after we differentiate it. And what we call this dy by dx or f prime of x is also the gradient function. Now, why do we call it the gradient function? I'll explain. Why can't we use the gradient formula? Fatma, how will you use the gradient formula on a curve? Please explain. How will you use the gradient formula on a curve?
Sir, I will, like, I should be given the points on the tangent, like the coordinates, 2 coordinates.
Okay. So what if you're only given the equation and you're supposed to find out the gradient of the curve at a certain point? What are you going to do then? You can't.
Then I guess I won't be able to.
Exactly. Okay. So which is why I said just hold on to your questions. Let me get through a couple of examples first and then I will take your questions, because chances are you'll find the answer to most of your questions once I am done with the examples. Okay. Even then, if you don't, it's okay. Like I said, ask as many questions as you like. All right. So this is step 1. Why do we call it the gradient function? The reason why we call it the gradient function is because it's a function which helps us find out the gradient of the curve at any point we like. Okay, we can plug in the value of x and we can find out the gradient at that point. Then comes step 2. Step 2 is plug in x equals to x1 in dy upon dx or f prime of x. Sorry, not of, or. Okay. Then what you end up with a certain value. When you plug in the value of x in a certain equation, you end up with a certain value. And what is that? That is basically the gradient of tangent to the curve at x equals to x1. Okay. Now, first, this is how we use differentiation. Okay, but before I give you an example, before we learn how to do an example, we need to learn how to differentiate. Okay, so we need to learn how to differentiate. So we're going to take a small detour. First, learn how to differentiate and then circle back to this. Okay, because if you don't know how to differentiate, then you can know all the theory in the world, but still not be able to apply it. Okay, so now we're going to learn something called how to differentiate. Okay, now the first category of functions that we learn how to differentiate, they're called power functions. Now, what are power functions? Power functions are basically simple expressions or simple terms with x that have a power on them. So like for example, y is equals to 5x to the power 4. Okay, this is the equation of the curve because it's y equal to, and what if we are supposed to differentiate it? Okay. So anyone who knows the answer to this already, please hold on to it. Okay, so here's what we're going to do. Dy upon dx can be worked out like this. We take the power, we multiply the power by the coefficient of x. So what will that be equal to? 4 times 5, that's equal to 20. Good job. And then we take 1 away from the power. Okay, what do? We take 1 away from the power. So 4 minus 1, what's that equal to? That's equal to 3. Okay, that's it. This is what you get when you differentiate y equals to 5x to the power 4. Now, this is just one example. Again, don't immediately start freaking out. Let me do plenty of examples, and then I'll take all your questions. Let's say we have y is equals to 4x cube. And let's say we have to differentiate this. Yes, like I said, I'm doing plenty of examples, so just hold on. Dy by dx is equal to 3 times 4. What's that equal to? That's equal to 12. And then you take 1 away from the power. So what's 3 minus 1? That's equal to 2. In fact, I'll do it step by step. 3 minus 1, what do you get? You get 2. So 12x square is your final answer. Yes, exponential equations, yes, you can call them, okay, but we call them power functions because they are uh, terms that have a certain power on x. Okay, let's do another example, and then we'll write down the general rule also. Okay, let's do another example, and then we'll write down the standard rule that we follow. Let's say you have y is equals to x to the power of 6. So what is the coefficient of x right now? If you don't see anything, that doesn't mean it's 0, it's 1. Okay, I can call it 1x to the power 6. Yes, always we take 1 away from the power. Now, if I differentiate it, let's see what we get. 6 times 1, that's going to be 6. X, let's take 1 away from the power. 6 minus 1, what's that equal to? So that is equal to 6x to the power of 5. There you go. Acha, why we do minus 1? So there is a long derivation behind this. We can do that, but not right now. Okay, we will do that, but I wouldn't suggest we do it right now. At the moment, let's just learn the standard rule and then we can do the derivation later on. Now, what exactly is the general rule? Let's look at that. The general or the standard rule. So let's say we have y equals to ax to the power of n. What do? We multiply the coefficient of x with the power on x. So what do we get? We get n times of a. And then what do we do to the power? We take 1 away. Okay, so we have n times a, x to the power minus 1. Okay. No, it's not that y questions are the worst. There is a there is a clear explanation behind the minus 1, which we can look into, but not right now. We will look into it, but not right now. Okay. All right, let's do another example. Let's say we have y is equals to 9x to the power, or simply 9x. So anyone who can tell me what will be the derivative of this? Now, when I say derivative, it's the same thing. Okay, don't get confused. Yep, it's going to be just 9. Dy by dx is equals to, so what happens when you multiply 1 and 9? You get 9. X to the power 1 minus 1, which is 0, or simply 9. Okay, 9x to the power 0 or simply 9. Okay. Okay. What if you have something like this? Let's say you have y is equals to 3. What will be the derivative of this? 0. Yes, 0. Why? Because with 3 you have x power 0. All right. If you don't have x, we can always write it as x power 0, right? Why? What is x power 0? What is anything raised to the power of 0? So for that matter, it's 1. Okay. So if I differentiate this following the standard rule, 0 times 3 is 0 and everything else becomes irrelevant. Even if you have x to the power of 0 minus 1, which will be minus 1, it's irrelevant. Okay. Now, if you think about it, the last two examples make sense. Okay, and why do they make sense? Tara, let me write this down first, then I'll explain. So if you have y is equals to a, where a is a constant, and then if you differentiate it, what happens? Dy by dx is equal to 0. Okay, so two standard rules that I want you guys to keep in mind all the time. y equals to 9x. Now, if you just look at y equals to 9x, what does this remind you of? What does this remind you of? It's an equation of what? Y equals to 9x. Anyone? Y equals to 9x is the equation of a straight line. Very good. Now, from this straight line, can you tell me what the gradient is? Can you tell me? It's 9. That's correct. Okay. And once we used the differentiation rule, we got the exact same answer. Okay. So y equals to 9x, we can see that the gradient is 9. And if we use the differentiation concept, we get exactly the same answer. Okay. What about y equals to 3? What is this the equation of? Y equals to 3, what do you think is the equation of? I know it's a straight line, but can you further narrow it down? What kind of a straight line? Y-intercept, okay. But y equals to 3 is the equation of what? Horizontal. Good job. Y equals to 3 is the equation of a horizontal line. Okay. What is the gradient of a horizontal line? This is what y equals to 3 will look like, right? It's 0. That's correct. And what did we get? Once we used differentiation, we got the exact same answer. So gradient of a horizontal line, we know from prior knowledge is 0. And through differentiation, we can confirm that. Y equals to 9x, we know from prior knowledge that the gradient of this line will be just 9. And we got the same answer through differentiation as well. Okay. Rule number 2 was that if you have y is equals to a, where a is a constant, the derivative or the differential, they all mean the same thing. Differential derivative, don't get confused. It means that the gradient is going to be 0. So every time you have a constant and if you differentiate it, what is the answer going to be? It's going to be 0. Okay, and why is that? We just saw that if you have a horizontal line and if you differentiate it, if you have a horizontal line and you find the gradient of it, it's 0. Okay, so let's do some more example questions and then I'll give you guys some questions to solve. All of this is for gradients? Yes. So I did some easier examples. Now I'm going to do some complicated ones. So let's say you have something like this. Y equals to x squared plus 5x plus 3. Now, can you guys differentiate this? What will dy by dx be equal to? 2x plus 5, that's correct. Okay, so now you have to differentiate all these terms at once. So how will you differentiate x squared? That's going to be 2x. Why? Because 1 times 2 is 2. You take 1 away from the power. And how will you differentiate 5x? That's going to be just 5. And then how will you differentiate 3? Plus 0. Okay, you don't have to write plus 0, but just in case you want to see what happens to 3 when you differentiate it, you can write it down. Okay, let's do another example. Let's say you have something like this. Y is equals to 1 over x cubed. Now, how will I differentiate this? Can I differentiate it immediately? No. Then what do we do? Yes, good job, Nayan. So first thing we need to do is something that I like to call making it differentiation ready. Okay, now what do I mean by that? In order to differentiate, you should have it first written like this, ax to the power n, which you don't over here. Why? Because x is in the denominator. So instead, I will write it as x to the power of minus 3. All right, now I hope everyone knows what rule I've used over here. Okay. Then can I now differentiate it? Of course I can. So now when I differentiate it, dy by dx is going to be, let's see, minus 3 gets multiplied by the coefficient, so that's minus 3. X to the power minus 3 minus 1 is going to be minus 4. So there you go. That's your answer. And then if you want, you can leave it like this, or you can write it nicely as minus 3 upon x bar 4. What if pi, okay, pi is what? Is pi a variable or is pi a constant? Let me ask you guys. Is pi a variable or is pi a constant? It's a constant. So if pi is in the denominator or numerator, doesn't matter, we treat it like a constant only. Okay? Let me do another example. Let's say you have something like this. Y is equals to cube root of x square. Yeah, sure, I can repeat it. So let's say we have 1 upon x cube. Now you can't differentiate something that looks like this. You got to make sure that you have x in the numerator and numerator only. Okay, we're talking about x. So we take x in the numerator, and what happens as a result? The power becomes negative. What rule are we using here? We're using the reciprocal rule. Now can we differentiate it? Now does it look something like this? Y equals to ax to the power n? Yes, it does. And that means minus 3 gets multiplied by the coefficient of x. So that's minus 3 only. We take 1 away from the power. So when we subtract 1 further from minus 3, it becomes minus 4. And then if you want, you can again use the reciprocal rule and make the power positive. But if you don't, that's perfectly all right. Okay, so what should I do over here before I can differentiate it? Question for you guys. We write 1 upon 3. 1 upon 3 or 2 upon 3? Yeah, x squared to the power 1 upon 3. Okay, if that's what you're saying, then yes, you're right. So first, we need to make a differentiation ready. I'll write it down over here. What I've done over here is that I haven't differentiated it yet. Differentiation ready. As in ready to be differentiated. So here also we need to do an additional step where we make it ready to be differentiated. So x to the power 2 upon 3 is what it becomes. Again, using the rule of indices. Now we can differentiate it. So in that case, this becomes dy by dx is equals to 2 upon 3 x to the power 2 upon 3 minus 1. Can we also do it directly in calculators? I don't think you can. In fact, I'm sure you can't do this directly in calculators. How will you differentiate directly in calculators? X to the... Do you mean the calculation part, as in 2 over 3 minus 1 and all that? Is that what you mean? Then what do you mean? So you can... How will you do that? How will you differentiate it directly using your calculator? Hmm? Okay, you know what that key is for? That key is not to differentiate functions. That key is to differentiate a function and plug in a certain value. Okay, that key is to plug in a function and differentiate a function and plug in a certain value. It's only to do numerical questions. Okay, numerical questions in the sense that you won't get to see the working behind it. It won't give you the algebraic working behind it. We have some questions where we have to differentiate and find out the gradient at a certain point. That is what we use it for, and we learn how to use it. Okay, but these questions you can't do directly in your calculator. Okay. All right. So I am now going to give you guys some questions to solve. Yeah, I'll give you guys some easy ones and then some complex ones. H is 3x square. Yeah, that's correct. And G is 5x power 4. Yeah, that's correct. Okay, so basically in these questions, you're just supposed to, there is one important key takeaway, and that is you don't start differentiating a question that looks like this or that looks like this. First, you need to simplify them, and then you need to differentiate them. Okay, so I'll write down the answer. Answer to part D is minus x to the power minus 2. Or if at the back you see the answer written like this, so don't freak out. Don't think that either you're wrong or the answer at the back is wrong. They're both correct. Just two different ways of writing the same answer. Answer to part G will be 5x to the power of, no, wait a minute, sorry, not 4. Yeah, 4. Yeah, 5x to the power 4. And then answer to part H is going to be 3x squared. Yeah, good job. Okay, let's do some slightly more complex questions now. Now I'll tell you which ones to solve. I'd like you guys to do part C, part D, part E, and part G. Okay, and this time I'll give you guys 3 minutes. So how we'll bring C in required form? Isn't it already in required form? All you have to do is think smartly about part C. I'll explain. X power 6 upon 2 f of x. Can I write it like this? F of x equals to 1 upon 2 x to the power of 6. Can I do that? Of course, yep. Now can you differentiate it? Using the same rules, 6 into half, what's that? That's 3, x to the power of 5. And this will be f prime of x. All right, we have the answers. This is the answer to part C. Answer to part D, I'll write it down. It's going to be minus 3x to the power minus 2. Okay. And then answer to part E is going to be minus 10 upon 3 x to the power minus 3. And then answer to part G. G has a bit of simplification that you need to do. But if you do it correctly, it's going to be 2x to the power minus half. Yeah. Here are the correct answers. Okay. So, all good so far? Yes or no? Yeah, of course, minus half can be taken down. If you do, then you can also write it as square root of x. You can write it as 2 upon x power half or 2 upon root x. You can write it like this also. Okay, and they're both acceptable. Unless, of course, the question says that you need to write it a certain way. Then you have to follow that. Yes, Ikra, that's also perfectly all right. You can differentiate x power 6 and then multiply it by half. So nothing to worry about. Okay. Is it f inverse? No. It's not f inverse. Had it been f inverse, I would have said f inverse. This is f prime of x. Okay, please don't confuse f prime of x with f inverse of x. F inverse clearly has a negative power, is raised to the power of minus 1. F prime of x has like a apostrophe. Okay, this is to distinguish a normal function from a differentiated function. Okay, so we use this symbol to differentiate a normal function, the equation of the curve, from its differential. Okay, so we're moving up a level or two, and you can judge that by the kind of questions that we're doing. So let's see what do we have here. Now it says here y equals to, acha, we've already done these questions like these, A, B, C, so I'm just going to skip them. How exactly are we going to do part D? Question for you guys. How will we do part D? There you go. Pause. Let me know when you're done having a look. Okay. Yes. First, multiply the brackets. Now, those of you who have done add maths in O levels or IGCSE, you guys may be thinking that maybe we can use the product rule. Okay. So my advice is do not use the product rule in AS Math because we don't have product rule in AS Math. Okay. So technically you can. I mean, there's nothing wrong with that. You will get the correct answer, but this method is not accepted. Okay. So first we need to expand, and we need to expand it like you would expand any other algebraic expression. So we multiply x and x, so we get x square. Right? Keep in mind we're doing part D. Minus 4x plus 5x minus 20. So this simplifies to x square minus, so plus x minus 20. And now can we differentiate it? Yes, we can. We can differentiate it like we have been doing so far. So what does this become? This becomes 2x plus 1. That's it. Okay. All right. What about part F? What do you suggest I do with part F? Let me write it down. Y is equals to 2x minus 5 upon x square. What do I do now?
We bring the power in the numerator and multiply it with the whole thing.
No. Or I think I understand what you're saying, but that's not exactly what we're going to do. This is what we're going to do. 2x upon x square. Yes, we separate the fractions. Minus 5 into x to the power upon x square. Okay. Yes, you advanced students might think that we can use quotient rule, but again, same rule applies. You can't use quotient rule in AS math. Okay. So what I can do now is I can simplify it further. 2x upon x square will become, it will become 2x to the power 1 minus 2 minus 5x to the power minus 2. Now 2x to the power 1 minus 2 can be further simplified, so this becomes 2x to the power minus 1 minus 5x to the power minus 2. Okay, now I haven't differentiated it yet. All I've done so far is, whatever I've done so far, the primary purpose of it was so that I can differentiate it easily. Okay, all this working was to make this expression differentiation ready. Now we can differentiate it easily. So dy by dx becomes minus 1 times 2, which is minus 2. X to the power minus 1 becomes minus 2. Okay, now this is where you have to be extremely careful. The minus sign we have comes as it is. Okay, what happens when you multiply minus 2 by 5? It becomes minus 10. And what happens to the power on x? Minus 2 minus 1 becomes minus 3. And then what will be the final answer? This is what the final answer is going to be. Pay close attention. It's going to be minus 2x to the power minus 2. And because of this minus from before and minus with negative 10, this will become plus 10 x to the power minus 3, which obviously you can always write as minus 2 upon x square plus 10 upon x cube. And this is your final answer. I mean, both these are acceptable as final answers, but yeah, this is how you do a question like this. Now, let me tell you something about calculus, okay? Only 10 to 20% of it is the concept, okay? The remaining 80 to 90% is algebra. Like, for example, the concept of differentiation we applied was here only, okay? This is where we applied the concept of differentiation. Everything else was what? Everything else was just algebra. All this is algebraic manipulation. All of this is also algebraic manipulation. And if you think about it, let's say you didn't know differentiation, okay? Let's say you didn't know differentiation. Is this something you could have done? Obviously, you could have done it till here. And again, let's say you don't know differentiation. If you were given this, can you bring it in this form? Of course you can. So this is the only part where we use the concept of differentiation. Everywhere else, it's all algebra. It's all algebraic manipulation mainly. Okay? And this requires a lot of practice. So if you've understood the concept, if you remember the general rule, and then somehow you're not being able to get the correct answer, it's not because you don't understand the concept, it's probably because you're making some sign error, some algebraic error. So what I was told Y isn't that applicable. What did you say? Can you say that again?
Said that we just take the power of, we just take the x square in the numerator and multiply with the whole thing.
Okay. Yeah, you can do that. You get the exact same thing. 2x to the power 2x multiplied by x power minus 2. But dekho, if you think about it, it will just add to our working. What you're saying is correct. Okay, technically that's what we have done also. This is what you're saying, right? Into x to the power of minus 2. Is this what you're saying?
Yes, sir. Yes.
Sorry, it's not 2x squared, it's only 2x. Okay, so you're saying we'll multiply 2x with x to the power minus 2, which will make it 2x to the power 1 minus 2. And then minus 5 gets multiplied, so minus 5x to the power minus 2. Yeah, what you're saying is correct. If this is how you want to do it, go ahead. Nothing to worry about.
Like, I can use this approach every single time I have this kind of question, or it would be differentiation different. It would be depending on the type of question.
You can. But the thing is, if let's say you have a constant, a common denominator, and you have multiple terms in the numerator, then before you start differentiating, it's always a good idea to separate the fraction and then go ahead with differentiation.
Okay.
Okay, so I would like you guys to solve part G and do part E also while you're at it. 2x square minus 3. 2x square minus 3. If you the whole thing squared, if you expand it, remember you have to use the identity. Okay, nobody's going to come in and tell you that you have to use the identity. You have to know yourself. If you have something that looks like a minus b or a plus b, the whole thing squared, it's a no-brainer that you have to use the identity. So this becomes 4x power 4 minus 2 into 3 is 6, 6 into 2 is 12x square plus 9. Achha, by the way, this is not dy by dx, okay? It's still the same function. So I won't write dy by dx equal to. Now that I'm differentiating it, I will write dy by dx, which is going to be 16x cubed minus, sorry, this is not power 4, this is power 2, minus 24x plus 9 becomes 0. So yeah, that's that. Okay, then what about part G? I'll write down the answer to part G. So it's going to be 14x dy by dx equals to 14x. Then it's going to be plus 3x to the power minus 2. Okay. Then minus 4x to the power minus 3. Yeah, that's correct. Be careful of the signs because that is also a very common mistake. All right. So we have learned the algebraic side of things. Now we're going to do some word problems. Okay. So as always, we'll start easy and then gradually increase the difficulty level. So far we were just differentiating and leaving it there. Okay. We only had to find out dy by dx and not use it anywhere, not use it to find out the gradient or anything. But here we are going to use it to find out the gradient. Yes, I can explain part G. So here's what we are going to do. Seven x square minus 3 upon x plus 2 upon x square. Okay. So 7x square minus 3x to the power minus 1 plus 2x to the power minus 2. All right. So I haven't differentiated it yet. Now I will differentiate it. So if you differentiate it now, 2 into 7 becomes 14x. And then if you multiply minus 1 with minus 3, this becomes plus 3x to the power minus 2. And then if you multiply minus 2 with 2, it becomes minus 4x to the power minus 3. Exactly what we got here. Okay. All good now? All right. You're welcome. Now, let's do part. Sorry, let's do question 6 now. Let's see what it says. Find the value of dy by dx. Okay, so how is this question different? Here you're asked to find out the value. So what exactly are we going to do now? What is the one thing different that we're going to do in questions like these? Yes. Substitute the value of x after we differentiate it. Okay. So y is equals to x square plus x minus 4. We differentiate it. So what do we have? We have dy by dx. Now, what is the purpose of this dy by dx? The purpose of this dy by dx is that it will give you the gradient of this curve at any value of x. Okay, so it will give you the gradient of this curve above at any value of x. So if we read the question, where do we want the gradient? We want the gradient when x is equals to 1. Okay, so x equals to 1 is where we want the gradient. So let's find out by plugging in x in the function. So 2 into 1 plus 1. So what is dy by dx equal to? Dy by dx is equals to 3. Okay, so what does this mean? This means that if you draw this curve and find out the gradient at this point of the tangent, what will you get? You will get 3. Okay, now previously, before we knew this, we used to do this by making a curve and then drawing a tangent, but we don't have to do that anymore. Okay. Acha, one question. What if you weren't given the y coordinate? What would happen then? You think we'll still be able to find out what we're supposed to? Yeah, nothing changes. So did we use the y coordinate anywhere? No, we didn't. Acha, what if we are only given the y coordinate Then what do we do? If, let's say, in the following part, the question doesn't give you the entire point. Instead, it gives you find out the gradient of the curve where x is, where y equals to 4.
So we just substitute y in the original equation.
Yes, we substitute y. No, 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 not x equals to 0. Where does that come from? We substitute y in the original equation to find out the value of x. Why? Because if you look at dy by dx, all the questions that we have done so far, what has dy by dx been in terms of? What has dy by dx been in terms of in all the questions that we have done so far? It's always been in terms of x. So that means if you want to find out the gradient using dy by dx, what's the one thing you need to know? We need to know the x coordinate. Okay, so if you don't know the x coordinate, what will you do? You will find out the x coordinate. How? By using the y coordinate. Okay, so if you're in a situation where we'll come across questions like these obviously later on, but just so you guys know, if you are in a situation where you're only given the y coordinate and you're supposed to find out the gradient, then what you do is you first plug in the value of y in the original equation, find out the value of x, then you differentiate it, and then you plug in that x coordinate. Okay? That's how you do it. So, I would like you guys to quickly do part B, and while you're at it, do part C also. And these are the kind of questions, by the way, that you can check using your calculator. But more about that later. I'm not going to teach you that immediately. We learned that. We learn those. We learn how to do that later. But at the moment, I would like you guys to do it like this without using your calculator. So the answer to part B is correct. It's 1/2. Good job. And the answer to part C, let me quickly check. Yeah, it's -5/4. Okay, let's do another question. So how are you guys finding this topic so far? Yeah, I can solve C, not a problem. All right. Good to hear that. Yeah, it is easy. It is easy. Yes, there are some difficult concepts, but if you are able to understand like the whole story behind dy by dx and how it works and what exactly you use it for, then it's not that difficult really. Can differentiation and sequence come in one? It can come in such a way that you can have part A and part B as independent, and one part could be differentiation, the other could be sequence, but not connected. I don't see a connection. Yeah, those questions can be challenging where you have to use the volume and surface area and all that. Yeah. But I'll tell you, only the students who struggle with algebraic manipulation find it challenging. The differentiation part, even of those questions, is not that difficult. I mean, differentiation and factors of polynomial came together as factors of polynomial. That was in admaths. Yeah, that was in admaths. In AS Math, you usually have a standalone question of differentiation and integration. Differentiation at max, you can find it with functions. In fact, not even with functions. It's usually a standalone question of differentiation. Because the topic is so lengthy, you have so many concepts that it's very difficult to combine it with some other topic. So I'm doing part B. Pay close attention. My answer to B is coming 11/2. Nope, something wrong. What is your dy by dx for part B, Fatma? Can you share that while I'm solving part C? So first thing you want to do in part C is that you want to separate it. Okay, so what do you get? You get 3x to the power -1 minus 2x to the power -2. Okay. Now, you differentiate it, so you have -3x to the power -2 plus 4x to the power -3. Okay. Then what's the value of x that we have to plug in? The value of x that we have to plug in is 5 plus 2. Yeah, I don't see anything wrong with that, Fatma. You're probably making a calculation error. Plug in x equals to 2 and you will get Acha, wait, it's not going to be 5 plus, it's going to be 0 plus. What happens when you differentiate 5? What do you get? You get 0. So it's going to be 0 plus 2x to the power minus 2. Anyway, so plug in x equals to minus 2. Let's see what we get. We get 3 into minus 2 squared plus 4 into minus 2 to the power minus 3. Sorry, minus 2 to the power minus 2. So this part I would suggest you work out using your calculator, and or if you want to do it mentally, this is what it will become. Plus 4 over minus 2 cubed, which means minus 3 upon 4 plus 4 over negative 8. So work this out using your calculator, see what you get. Minus 3 upon 4 minus 5 upon 4. Take a. Nope, it's not minus 1, it's minus 5 upon 4. I think you've made a calculation error. All right, here's a suggestion. Once you've worked out the differential, then with the value of x, my suggestion would be to work it out using your calculator. Okay, plug it in as it is and let your calculator do all the simplification and calculation. Okay, and you can just write down the final answer. You're not going to get any marks for showing this working. This was just for you guys. Okay, now, question number 9. Can you do B as well? Yeah, I will just do the differentiation, okay? So 5 minus 2 x to the power minus 1. Now if you differentiate it, what do you get? 5 becomes 0. Minus 2 into minus 1 will become positive 2 x to the power minus 2. So what do you get? You get this becomes 2 upon x square. Now 2 upon x square. Can you plug in the value of x, which is 2? If you do that, 2 square is 4. 2 upon 4 is 1 upon 2. Answer is minus 8. All right, you're done with the question already. That is the correct answer. Good job. Khair. So how exactly are we going to do question number 9? You think question 9 has enough information? Or you think there's something missing? All right, if you think it has enough information. X equals to 0. How do you know that? The question doesn't say that anywhere. X equals to 0. Are we...
The curve that crosses the y-axis.
Yes. Okay, so we're not assuming that x is equal to 0. The curve is crossing the y-axis. That means at that point x equals to 0. Stationary point, where did that come from? We haven't done anything related to stationary point yet. Okay, so don't mix up the concepts. Right now, we're just finding gradient. So this is the equation of the curve. Y is equals to 5x squared minus 8x plus 3. And we need to find out the gradient where the curve crosses the y-axis. And you can see we don't even know what the y-intercept is, but frankly, we don't even care what the y-intercept is. Why? Because all we care about is the value of x. Isn't that stationary where gradient is equal to 0? Here, the gradient is not equal to 0. Please read the question carefully. We're supposed to find the gradient. Okay, the question doesn't say that find out the stationary value or the stationary point or anything like that. We're supposed to find the gradient of the curve at the point where the curve crosses the y-axis. Okay, so read the question carefully. Don't make any assumptions. This is what we're looking at. Here's the curve. We're supposed to find out the gradient of the curve where it crosses the y-axis. Okay, so let's differentiate it. Dy by dx, what do we get? We get 10x minus 8. We need to know what the value of x is so that we can plug it in. And if you do that, you get dy by dx equals to minus 8, which means the gradient of this curve when it crosses the y-axis is minus 8. Yeah, that's correct. Good job. So how is this question different from the questions that we have solved so far? 9 is y. Are you sure about that?
Actually, it was over here they had given us the gradient and we had to find the coordinates. Whereas
Yes.
in the coordinates we had to find the gradient.
Yes. So here we are given the gradient. Okay. And how will we know we're given the gradient? All we have to do is read the question. Okay. Doesn't take a lot of effort to read the question. So please make sure you do that. Find the coordinates of the point. So again, one very strong hint over there, plural. That means we're likely to get more than one. on the curve so and so where the gradient is 9. Okay. So after reading this question, if you're still wondering how we know the gradient is 9, that means you haven't really read the question carefully. Okay. So the gradient is 9. That means dy by dx is equal to 9. So what do? We take this equation, x cubed minus 3x minus 8. We differentiate it. You get 3x square minus 3. And now you know what this is equal to. It's like, in coordinate geometry, sometimes you're given the x and y coordinates and you have to find the distance. Sometimes you're given the distance, you have to find out maybe the x or y coordinate. So exactly the same thing over here. 3x square minus 3 equals to 9, which means 3x square equals to 12, which means x square equals to 4, which means x is equals to plus and minus 2. Now, because we have two different values of x, we are going to get two different values of y also. So one by one, plug in both the values, plug in 2 and minus 2. If you plug in x equals to 2, now I'll just write down the final answer. If you plug in x equals to 2, you get y is equals to negative 6. And if you plug in x equals to minus 2, you get y is equals to negative 10. And then write your answer nicely, which you guys have, most of you have written, 2 comma negative 6 and minus 2 comma negative 10. That's your answer. Job done. Okay, one last question of the day. And then you guys can leave. Here it is. And I hope I don't have to help you guys at all in this question. If I have to, I will, obviously. But I hope I don't have to. A equals to 2 and B equals to minus 7. I think you guys are on to something. Yes, that is the correct answer. A equals to 2 and B equals negative 7. Good job. So I hope everyone has been able to solve this question correctly. Okay, so I'll do the working, not entirely, but I'll just do the basic working of it. We have two unknowns, right? Normally when we have two unknowns, what does that mean? What is that usually pointing towards? If you have two unknowns, simultaneous equation. That means we need enough information to form two equations. And if you read the question, you might think that we don't have enough information, but we do actually. Okay. So first we have a point through which this curve is passing. Okay. So that means I can plug in x as 3 and I can plug in y as minus 3. Okay. So if you plug in y as minus 3 and x as 3, this is what you get. 9a plus 3b equals to negative 3. Let me write it nicely. 9a plus 3b, which is equal to negative 3. All right, and this is one equation. Then if you think about it, if you read the question carefully, you are also given the gradient. Okay, you can differentiate it first, Fatma, nothing to worry about. You can differentiate it first. Okay, you're also given the gradient. So what is that? That is your dy by dx, which is equal to what? Which is equal to 5. So now if you differentiate it, y is equals to ax squared plus bx. If you differentiate this, so dy by dx gives us 2ax plus b. Okay, so you apply the same rules of differentiation. Just because it's a and b doesn't mean that you can't apply the rules of differentiation. You apply the same rules. Only difference is that you don't know what the value of a and b is yet, so you just leave it as it is. Okay. Now in this equation, I can plug in x as 3 and dy by dx as 5. Okay. So if you do that, you have 5 is equals to 6a plus b. I say yeah. So now you have your other equation. Let's write it here. 6a plus b equals to 5. Now solve these two equations simultaneously, and if you do them correctly, you will have a equals to 2 and b is equals to negative 7. And that's it. So good job, those of you who did this question correctly. That means you're reading the question carefully and you've understood the concept of differentiation as well. We're going to keep it till here only. In the next class, inshallah, we are going to do some more complex questions of differentiation where we will learn how to differentiate composite functions. Okay, and then if time allows, in the next class only, maybe we will do equation of tangent and equation of normal. Okay. How long will this be? Okay, so I'm expecting one class for composite functions and equation of tangent and normal, then another class for applications of differentiation, then stationary point. So I think coming week we should be done with differentiation, inshallah. Coming week. So by next Saturday, hopefully we'll be done with differentiation.
So can you tell us the method you were saying? I will not tell you yet, but later to find the answer
Oh
from
yeah,
the
yeah,
calculator.
yeah, of course. So, Tara, let me take a picture of my calculator first. All right, so this is the key that we're looking for, this one. But before you press it, make sure that you press shift. So press shift and then press this key, so you will see something like this, d upon dx, and then you'll have some space to type the function, and then you'll have x equals to with a blank. Do you see it? Fawaz, do you see it? Okay, great. Acha. I'll tell you how to use it. So when you press it, this is what you're looking at, right? D upon dx, and then in the bracket, you're supposed to type the equation of the curve. Okay, equation of the curve. And then you will have x equals to, and then you'll have again some blank. Here you write down the value of x at which you wish to find out the gradient. So if I, let's say, do question number 9 with the help of this key, so here's what I will do. D upon dx, 5x square minus 8x plus 3. So the good thing is the calculator will do the differentiation for us as well, and it will plug in the value and give you the end result. So work this out using your calculator. You'll notice that you get minus 8 as your answer. So this is a more direct way of checking your answer. Okay, you can use this. Remember, you can only use this to check your answer. Okay, at no point do I want someone asking me that, what if you don't show the working? Well, if you don't show the working, you don't get the marks. Simple as that. Yes, obviously you write the entire equation.
Can we get the coordinates from the calculator if we give him the?
No, we can't do that. You can't do that. You can't. You can't do that. You can't do reverse differentiation. Yeah, so alpha and x. Press alpha and x, and that's how you will type the equation. If you have a calculator like these, like one of these, you have a dedicated key for x also. It's right here, this one. Or you can press alpha and then press bracket close, so that way you'll have x. And if you have if you have some other calculator, then you can do the exact same thing, alpha x. Okay. Learn this, get a good grip on this, and make sure that you guys use this to check your answer. Can you show how to do this in calculator? I just did that, didn't I? We had for 3 years, never realized that we have dedicated key. Okay, now you guys know. Fatma beta, I just did that, didn't I? Type the equation here. I mean, do we have to add brackets? No, you don't have to add brackets. The calculator will have the brackets open for you. Okay, so as soon as you press shift and you press the key that I just mentioned, the calculator will, all you have to do is type the equation and write down the value of x where you're supposed to find the gradient. Okay, so if you press shift and if you press this key, the calculator will have something like this for you. In the bracket, write the equation. After x, write down the value where you wish to find the gradient, press the equals to sign, and just wait for the magic. Okay, so I'll stop here. I have a video on this as well. I'm pretty sure I have a video on this. I'll share it with you guys, and you guys can watch that. Okay, so I'll stop here. See you guys, inshallah, on Tuesday. Take care, everyone. Have a nice weekend. Allah Hafiz.